Suppose you have x minus 1 divided by 4x squared minus 4x plus 3 dx. Well, okay. You might say we see that the degree of the denominator is larger than the degree of the numerator. So step 1 is to write the denominator in factor form. Well, okay. Here we have 4x squared minus 4x plus 3. Here we have a quadratic expression, and we're going to write it in factored form. So note that here you have ax squared plus bx plus c, and if you use quadratic formula, the discriminant, the delta, b squared minus 4ac, or the delta or the discriminant, it's going to be negative 4 squared minus 4, minus 4 times a, which is 4, okay, and c, which is 3. So as you can see, you get 16 minus 16 times 3, or 16 times negative 2, negative 32, which is negative. The discriminant is negative. What's the meaning of that? It means that if you want to apply quadratic formula, negative b plus minus square root of delta divided by 2a, this guy gives you complex solutions. So you have 4 plus minus square root of negative 32 divided by 2 times 4. We get complex solutions. So what's the meaning of that? It means that we cannot factor this out using real solutions. So how do we resolve this issue? In step 1, we cannot write this in factored form using real solutions. It means that we cannot go to the next step using partial fractions. What do we do then? Well, let us take a look at this. You might say, hey, why not using substitution? If you want to use substitution, you get 4x squared minus 4x plus, it's 3 what I wrote down, 4 plus 3. If you want to write it as u sub, use the technique of u sub, you get 8x minus 4. 8x minus 4. Well, okay. 8x minus 4. Then in that case, if I just multiply by 8, my dx, it doesn't work for the numerator. If you use u sum for x squared minus 4x plus 3, then du is 8x minus 4 dx. Well, okay. It means that I have to have 8x minus 4, or if I just factor out 4, du is 4, 2x minus 1 dx. It means that I need to have 2x minus 1 times dx, but I don't have 2x. If I multiply by 2, I have to distribute 2 into parentheses, 2x minus 2. So it creates a 2, not 1. So how do we resolve this issue? Well, since we have two x minus 1 times 4, you might say, well, I can multiply the numerator by 4, divide a fourth, and then, so 2x minus 1, if I factor out 2, I get x minus a half. This guy can be written as negative a half minus a half. Then you can separate those two fractions and start working with those two fractions. So this is our first approach. We get the integral of 1 over 8 and here we have x minus a half for x squared minus 4x plus 3 dx. And then we can separate this as so here you just get this integral as minus a half and negative a half. We don't need any coefficients here. We get x minus a half divided by 4x squared minus 4x plus 3 dx plus the integral of negative a half 4x squared minus 4x plus 3 dx, and start dealing with these two integrals separately. Or you can complete the square of the denominator. For x squared minus 4x plus 3 can be written as, so here you get 4x squared minus 4x when you have ax squared plus 2ab plus b squared, this is equal to a plus b squared. So this is what we're trying to do. We're trying to add and subtract a number that helps us to write this guy down into parentheses, the first term plus the second term squared. So here you have like 2x squared minus 2 times 2x. So you need a 1 plus 1 minus 1 plus 3 equal to 0. We get 2x minus 1 squared plus 2. I need 0, just completing the square. So this integral can be written as the integral of, we copy down the numerator divided by our denominator, which is 2x minus 1 squared plus 2. So this can be separated as x times dx divided by 2x minus 1 squared plus 2 plus the integral of -1 dx divided by 2x minus 1 squared plus 2. Very well. Here we can say u is 2x minus 1 in the first integral, and du is 2 dx. So use that here. Is 2 dx. So we can just calculate this integral. -1 divided by 2, the integral of du over u squared plus 2. And for this integral, we have u squared plus 2, and our u is 2x minus 1. So 2x is u plus 1 divided by 2. Instead of separating these two, we could just start from the beginning and use that over there. So then you can separate that. This is the integral of, and here you have 2x minus 1 equals to u. So 2x is u plus 1. So x is u plus 1 divided by 2. You get u plus 1 over 2 minus 1. And here you have du divided by 2, u squared plus 2. Again, it doesn't matter if you separate it at the beginning or just use up and separate these two integrals. This is the integral of u plus 1 minus 2, let's write a half, and a 4 divided by u squared plus 2 du. This is the integral of u minus 1, which is a 4 u du u squared plus 2. Another substitution here. And here we get negative 2, 4 integral of du divided by u squared plus square root of 2 squared, which is arc tangent that you learned before. This is 1 over 8, the integral of, for example, a new variable or u sub, or just substitution with it, and negative of half integral of du over u squared plus square root of 2 squared. So this is obviously LM, and this is obviously arc tangent. So here we have 1 over 8, Ln of absolute value of w. W is u squared plus 2, and u is 2x minus 1. So 2x minus 1 squared plus 2 minus 1 over 2, and times 1 over square root of 2, and inverse tangent of u divided by square root of 2, 2x minus 1, divided by square root of 2 plus constant of integration.